We're here today with Maria Curie and Albert Einstein, who just released an amazing book about quantum physics called The Theory of Almost Everything. And today they're here to answer a few questions. First off, okay, and last question of the day. Since it's become such a sensitive topic, could you give us your opinion on radioactivity? Do you think it's a bad thing?
No.
Yes. I see there's a bit of a disagreement. Alberta, why don't you start?
Well, I suppose we should start with a short introduction on what radioactivity really is. Basically, it has to do with atoms, which are made up of a nucleus containing protons, positive particles, and neutrons, neutral particles. And orbiting around this, there are electrons, negative particles. Since neutrons have no charge, they can vary in number without affecting the atom's chemical properties, forming isotopes. But if the ratio between neutrons and protons becomes too large, it creates an unstable isotope.
When one of these is formed, it is called radioactive, as it has the capacity to spontaneously release different types of particles, alpha and beta, or energy, gamma.
Exactly. And specifically these last ones are very penetrating, which can cause severe damage, such as cell destruction and genetic mutations.
Well, that's true, but gamma rays are also used in various important procedures, such as in the medical field. For example, have you ever heard of a PET scan? No, actually, I haven't. So, PET stands for positron emission tomography, and it's a scan that produces detailed 3D images of the inside of the body. It is generally used to evaluate organs and other tissues for the presence of a disease or other conditions. They're most often used in identifying cancer, saving thousands of people's lives.
That's definitely true, but when these rays break DNA strands, mutations can be formed, sometimes becoming tumors, and causing the need for PET scan in the first place.
Sure, you're not wrong, but you cannot exactly determine how dangerous it is without considering the amount of radiation you're exposed to. In fact, we must remember that everyone is always exposed to a certain amount of radiation called background radiation, and that amount isn't dangerous for us at all.
That being said, precautions are still very important when working with radioactive materials, as we want to avoid making the same mistakes we made in the past, such as the ones that led to nuclear disasters like Chernobyl's or Fukushima's. For example, during a routine safety test, the operators at Chernobyl's Unit 4 reactor committed a series of mistakes that led to a massive explosion and a subsequent fire. The operators had turned off several safety systems and did not follow proper safety procedures. This caused death, cancer, birth defects, and health problems, with close to 2 million people affected.
You're once again correct. Tragedies have happened because of radioactivity. Although, as you mentioned, by following the correct safety procedures with precision and designing the structures carefully, disasters can be avoided and radioactivity can become very useful. Other than producing electricity, which is its most well-known use, it is essential in the carbon-14 dating method, a scientific technique used to determine the age of organic materials such as wood, bones, and charcoal, up to about 50,000 years old. The method is based on carbon-14 being a radioactive isotope of carbon, and it is always produced by the Earth's atmosphere by cosmic rays. This method is widely used in archaeology and geology. Great! I know all three of us would spend hours talking about interesting topics such as this one. But unfortunately, we have run out of time. In the end, we can state that radioactivity is indeed very dangerous, but extremely useful at the same time. You just need to work in a safe and controlled environment. Thanks so much to both of you for your time. And I'll see you guys next week.